We have a lot of content at the summit about containers and cloud technology, and the goal of this presentation is to give you sort of a foundational understanding of this, so you can sort of conceptually understand what we're doing with this technology, why we want to use it, and then leverage that in sort of further sessions which are more technical, deep dives, that sort of thing. Or if this is the only session that you catch, you'll gain some knowledge about sort of why InterSystems is so excited about this technology and why we're talking so much about it. So let's just get into it. My name is Joe Carroll. I work in product management at InterSystems. Before I was in product management, I was in support. So some of us may have talked on the phone in the past. So a lot of these operational problems that we're going to talk about running IRIS or software in the real world, I lived and breathed it in support for 5 years. And so it's near and dear to my heart, some of the problems you can solve with this technology. I like to start my presentations with an outline to make sure that everybody understands sort of what we're going to talk about and why and where we're going. And if I lose you at any part, we'll come back to the outline and you can sort of reorient yourself and make sure that you sort of know where we're going next. So really this is a why, what, and how of containers with IRIS. So we'll talk about why we want to use containers in the first place, the problem that they're solving for us. There's lots of problems that they solve, but we'll narrow in on the most common problem that people will solve with this technology. I will give you a little demo of that. Then we'll talk about what containers are. We'll talk about some definitions, some words that will come up again and again at the conference. And then we'll talk about the difference between containers and virtual machines, just because it's a very common question and some of the terminology is the same. And then we'll talk about IRIS containers specifically and some features that we've added to the product to ensure that you can run with containers effectively and do what you need to do to solve problems. Does this make sense? Okay, cool. So the problem that we're trying to solve with containers is a problem called system drift. So who here has heard of system drift? Okay, what about gauge change problems? What about it works on my machine? Yeah, everybody's heard that one, huh? The most common problem in software. Right. So those of you who are not familiar, let's just sort of go through it. So in software development, doesn't matter what sort of software development you're doing, startup, enterprise, somewhere in between, okay, you have separate development environments, or separate environments that your software runs in. I have 3 up here, development, testing, and production. Some people have staging, some people do things that are a little bit more continuous. There's lots of different ways to do this, but fundamentally you have a different environments that your software runs in during different stages of the software lifecycle, okay, and different engineers that are working with it in each one of these locations, or sometimes not engineers working with it in these locations. So in development, you have your developers writing code, right? The goal of this environment is to generate new features, do bug fixes, whatever. It might be a developer laptop, it might be a shared dev machine, but fundamentally this is where we're generating product. Then the software moves from there to testing environment, where we verify that the software does what it's supposed to do, right? It passes our unit tests, the new feature works, there are no regressions, oh no, we found another bug, and then it goes back, right? And then finally in production, we have support engineers, DBAs, actual users working in our environment, okay? But there's a problem here, and the problem is that the picture isn't so simple, okay? So as your software, or as your company grows and as you scale up your software development cycle, you start to have many, many different environments. Okay, so maybe have many development machines, many testing machines, some production machines that are bigger, beefier than maybe my developer laptops. And so if a developer makes a change to the application or a dependency of the application, for example, the version of Java that's running, we might have an organizational problem ensuring that that version of Java is changed in all our environments. So if the number or version of cache or version of IRIS or what have you, right? It could just be a code change, but lots of times we're talking about dependencies and libraries, okay? And so when this number of systems is manageable, when they're few in size and we have teams that are doing a good job watching this, okay, there isn't any problem. We're able to run smoothly, okay? But you really don't have pictures as simple as this, right? Your environments look something more like this, okay? You have many, many dev environments, many testing environments. They're all doing different things, okay? You have many production end user sites, all right? And all of these things are existing in the world, solving real problems for us and necessary to do the development and testing and, the things, and running the systems, the things that make us money. But we have a sprawl of these things, and keeping them all in sync is really challenging. So in this picture, if one developer decides on their own to change a dependency of the application, how do I ensure that that change gets reflected in all the other dev environments, in the testing environments, and in production? Okay, so as the pictures start to look like this, especially it's going to be massive and we do cloud automation and that sort of thing, we have major organizational problems keeping our systems consistent and cutting down on system drift. I can't tell you how many times I've been on the phone at 2 in the morning working on one of these pink production systems, and the reason it's working somewhere here but not in development is because the development environment was too different than the production environment, or vice versa. Right? And by the way, it's not just developers that change dependencies that don't get reflected in other environments. Lots of times it goes back to where your support engineers will fix something in production, go back to bed, and then 3 weeks later you'll see it again because we pushed a new change. Okay, so managing these systems and keeping them in sync is a real challenge for software organizations. Okay, and there's a lot of friction and time and energy and money lost every time we screw up, right? And especially if humans are doing it, even if humans aren't doing it, we need better tools to manage the consistencies across our environments. Does this make sense? Okay, cool. So let's talk a little bit about containers, and unsurprisingly, I'm sure I'm going to tell you that containers are going to help you solve this problem. But in order to talk about software containers, I want to give an analogy to shipping containers. Okay, so here's a picture of the Boston Harbor in 1812. So what used to happen when we're moving goods around is that every day guys would show up on the docks and they would be moving goods from ship to truck to train and vice versa, and all these combinations, taking things off, picking things up and putting them down, right? But every day it's different, right? Every day you would show up, some days there's boxes, some days there's barrels, some days it's heavy, some days it's light. There are all these rules about how things can be stacked and how things get moved around. And what the shipping industry started to find was that as shipping scaled up, as they were pressed to do globalized shipping and to move faster and faster, that each time their goods changed environment, they were losing time and money and energy, as well as a high potential for injury. It's a real thing. People used to measure the efficiency of shipping by mean time between fingers, by sort of how often somebody would lose a finger moving things around. Okay, so that's not cheap. There's a lot of, as I said, money lost across these gauge changes. So what did shipping do? Well, they standardized. Okay, when it first came out in the 50s, the shipping container was this crazy, wild idea. There's one guy who was like, this is the future, and everybody's like, you're freaking crazy. Nobody's gonna put it in a box, like, that's dumb. But nowadays, you don't see any goods moved outside of a shipping container. Okay, and the reason why is that shipping containers standardize the infrastructure for moving goods around. So it doesn't matter whether it's running on a truck or on a train or on a ship, the format is always the same. So instead of guys showing up at the docks to move boxes and barrels inefficiently, we have cranes that are built to work with shipping containers. We have infrastructure that's designed to work with a standardized, consistent package. Okay? And what that allows the shipping industry to do is operate much more efficiently across gauge changes or systems in which their goods move. Unsurprisingly, we're going to take this concept again and apply it to our system drift. So we're going to take this concept of the shipping container and the standardization and the consistency that we get across environments, the standardization of tools and the way that we package things, and we're going to apply it to our system drift problem. Okay, so instead of manually or automated, in some automated fashion, having different things running in different environments, we'll standardize to the same box, a container, and we'll run that consistently and repeatedly across these environments. Yes? Making sense? Okay. So let's do a demo. So here I have a Docker command, and if you're not familiar with container technology, Docker is the most popular container runtime. It's a way of basically setting up and running software containers, and we'll talk a little bit more about what a container is in the next section, but I want to just demonstrate this consistency and repeatability point here, okay? So there's a Docker store. We have IRIS listings on the Docker store. So if I click here, I can see that I can run InterSystems IRIS community using some Docker commands, okay? So I'm actually going to do this over here. Can everybody see okay in the back? Here. So what I'm going to do is this Docker run command. So normally if I want to run IRIS on my laptop, what I'll have to do is go down to the distribution site, I'll pull down a kit, I'll unpack it, I'll run the installer, I'll click, 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 yes, no, configure it the way I want, okay? With containers, we're not going to do that. What we're going to do is run that standard portable, like the shipping container, the same in every environment. So here I have Docker run, that's going to start a container, in detached mode, which means it'll run in the background, and then I specify the template, the image that I want to base this container off of, InterSystems IRIS community, okay? So if I do this, I'm now running a container. I can show you with container ls, which kind of wraps around, so I have this filtered one, which shows it a little bit better. So I have a container identifier, I see that it's up and running, and then it's starting, and then it says I'm running the IRIS image. So if I go into this container, I will see that IRIS is in fact running. So here we see that IRIS is running inside the container. So no install, no manual configuration, nothing like that. I can use this Docker command to run the same consistent thing everywhere. So it doesn't matter whether it's running on my laptop, on a testing system, production, in the cloud, wherever, it will behave in a consistent and repeatable way. We're standardizing the same way that we standardize with shipping containers. Make sense? Okay. Okay, so we talked a little bit about why we want to use containers and about getting consistent, repeatable deployments of our software across environments. Let's talk a little bit about what a container actually is, which will hopefully make that command I just ran make a little bit more sense. Okay? So what's a container? There are two primary terms that we use when we're talking about containers. Okay? The first one is an image. Okay? And so an image is this standardized, portable, runnable software bundle. Okay? In my Docker command, that was Docker run store InterSystems IRIS community, right? That was the image. So when we talk about standardizing with containers and getting consistency across environments, we're actually talking about the image, not the container itself. We're talking about building a binary file which contains the application code and the dependencies of that code. So in my example that I ran, that container image contained IRIS install and everything that IRIS needed to run. So if it was a Java application, it would be the Java code and the Java runtime baked into that image. And most importantly, when we build a container image, we make it read-only. And so this allows us, or immutable, you'll hear people say, well, this allows us to get consistency across environments. So when InterSystems builds and puts out there that IRIS container, we make it read-only such that we know that everybody who pulls it down, no matter where they're running it, will get exactly the same thing. And it doesn't change across environments. The other key term is a container itself. Okay, so a container is one of these images, that application code and the dependencies of that code, basically in motion. Okay, it's an image that's executed in isolation and under resource control. So in my example, you saw me do a docker exec command, which got me into my container. By default, I wouldn't be able to see anything running in that container from the outside. Okay, that's because the container is running in isolation and under resource control. Okay, and if you're a Linux geek, there are two Linux technologies that are enabling this, C groups and Linux namespaces. These just allow you to do that isolation and resource control. And so when I run that Docker command, this is what Docker is setting up for me. It's taking that binary file, which is that image, setting up resource control and isolation, and executing the application running in it. Okay? So if you're familiar with object-oriented programming, there's another analogy here. An image is like a class definition. and a container is like an instance of that class. So an image is sort of the template that contains everything that we need. It specifies what this is going to be when we run it, and a container is sort of the active version of it, like an instance of that class. So every time we start and stop containers, we will always start fresh from the same image to get that consistency across our environments. So I'm going to stop here for questions. Is this making sense? Cool. Let's talk a little bit about the difference between VMs and containers. Okay, you might have noticed that some of the concepts here are very similar. Okay, the concept of an image and a virtual machine image and or a snapshot and a running VM and a container image and a container. Okay, and the problems that they can solve are very similar, but fundamentally these are different technologies. Okay, so and sorry, left side of the room, there are more people over here, so I'm going to point at this one. So as you can see, in the virtual machine situation, we have infrastructure, could be a laptop, server racks, the cloud. We have a host operating system that's running something called a hypervisor, which is going to get us that virtualization. There's other virtualization technology, but in this picture, a hypervisor. And then each one of those brightly colored vertical things is what we would call a VM, okay, a virtual machine. So it has a guest operating system, and then it has binaries and libraries in the app. So that would be the application and the dependencies of that application. Java and the JRE, object script code, and IRIS or cache, right? In the container picture, we see something that's very different, okay? We have this underlying infrastructure still. We have a host operating system again. We have this Docker engine, which I'll come back to in a second. And then we have our brightly colored things, which are analogous to the ones over there. So green here is green over there, vice versa, okay? And they contain the application and dependencies of the application. But you'll notice in this picture that there is no guest operating system inside containers, okay? So by default, containers do not emulate a full operating system. And this Docker engine right here maybe would be better off to the side, but what Docker is doing is it's setting up the walls around our container, that resource control and isolation, but fundamentally these applications are running directly on this operating system. Okay, so the containers are running directly on the host operating system. They don't have their own emulated operating system. So to go through an example of that, if we have this operating system that our actual infrastructure is running, let's say it's CentOS, and our applications, and this one I call out the red ones, are running Ubuntu. Okay, so in the virtual machine situation, that's a real operating system. It's a real guest operating system. In the container situation, it's more like binaries and files, which make it look and feel like Ubuntu, but it is not a full operating system inside the container. And so if I'm running the fork command in this red container, in that app3 layer way at the top, that fork will be fulfilled, a fork being the Linux, or a Linux command to get a new process. Okay, that command will be fulfilled by the Ubuntu operating system, the Ubuntu kernel. In this situation, that fork will be fulfilled by the CentOS kernel. So this is a fundamental technical difference between virtual machines and containers. Both offer isolation, resource control, and portability of their images, but containers run directly on their host operating system. They do not have a guest OS. Okay, so there's a couple implications here. The first one being very obvious visually, which is that containers are smaller. Okay, they're going to be much smaller than a virtual machine image. They're going to be much faster to start and stop because they don't contain a full operating system inside them. And they're going to be easier to move around. So pull down from the internet, push to a machine. The file size is going to be much smaller than, the VM. So a container image will be at most a couple gigs, and a VM you're starting at like 20 gigs or 30 gigs for your VM image, right? They're big. I'll take that question in just a second. And one more thing here is that as the application designer, you have to understand what is going to happen when you make calls to the operating system. So this is the biggest difference here. You have to understand if you're writing a container application, you're going to be dealing with the host operating system. Even if you start from the Ubuntu flavored container, you're still going to be running on the OS, whatever it is. So what's your question? I'm supposed to give you this because there's a recording.
Yeah. How do you differentiate the guest OS and the host OS? What's the main difference?
Right. So the difference between the host operating system and the guest operating system in the virtual machine situation, I mean, one of them is running the hypervisor. So for example, on my Mac laptop, I'm running Mac, whatever they call their OS, and I have vFusion or whatever the VMware software is, and I can run a Windows VM. So the guest operating system would be the Windows VM, and the host operating system would be my Mac, because that's what's running the virtualization technology, and then the VM itself is a Windows VM. Does that make sense? We can talk after. Okay. Are there other questions about this slide? Can you, sir, go back to that microphone, if that's okay? Thank you. Thank you.
Just to summarize, is a way of saying this that when you create a container,
Yeah.
it contains an operating system, as opposed to it contains just the specifics of your application that you're then going to like unload onto an operating system.
No. So it's the opposite of that. So your container does not contain an operating system in the same way that a virtual machine does. Your container uses the operating system of the host machine. So it's going to, so this red thing right here, when it makes calls, it calls into this guy down here of operating system calls, and this VM right here, when it makes calls, it's going to be fulfilled by this guest operating system. And then eventually there's a hypervisor and blah, blah, blah. But these three containers here are all sharing the same operating system, this guy down here, where these VMs each have their own dedicated operating system. I'm glad I stopped. You might have to turn it on.
1, 2, yeah. So does that imply that if we want to support multiple operating systems, we would create a container for each one, assuming the operating systems have different semantics in their system calls, for example?
No, not necessarily.
Are there mappers?
So more or less, what's going on is that containers are taking advantage of POSIX compliance. Okay, so there are standards for how the fork command behaves, and if the operating system you're running on is compliant with that, then you can run the container on and expect particular behavior of how it works. That being said, as we get into things like running containers on Mac and Windows, they're actually going to be, Docker will be running like a virtual machine with the Linux kernel on it to fulfill those commands, right? Because you can't execute fork on Windows and expect things to happen, right?
And if there are differences between Linux variants, then you would try to avoid taking advantage of them if you're creating a container?
Yes, and what you would want to do, we do test on all these things. So for example, InterSystems builds an IRIS container, but we don't, that's based on an Ubuntu flavored container. Okay, but we just tested on this giant matrix of all these different platforms to ensure that it behaves consistently in these ways, but we don't build specific container images for specific platforms. The one difference is that there's this concept of a Windows container, which is exactly the same thing as Linux containers, which we've been talking about so far, but it's implemented in Windows, right? So we'll do Windows system calls and isolation and that sort of thing. Cool? If you have more questions about this, come to the Tech Exchange. We have a bunch of people who know about this. Yell at me in the hallway. I can answer more questions. Okay. So I had a demo here. I'm going to skip it because we spent time on questions. But what I was going to show you is the isolation that containers set up for you. So I was going to take that container that we ran before. I was going to do an IRIS list outside of that container, and you would see the irises installed on my Mac in the normal manner, but you wouldn't see that containerized iris there. But if I exec into that container using a container ID in the middle there, and then I did an iris list, I wouldn't see all of the irises on my Mac. I would see only the iris running inside my container. So they're isolated by default. In addition, I would run then some process list commands. So you can, if you install Docker, you can run these on your own machine. I would run some process list commands to show you that inside the container, I only see processes which are from that container. I don't see everything that's running on the system. I'm isolated in my own process namespace, but outside of the container, I do not see that stuff, okay? I would see all of the processes running on my Mac that are doing the operating system and that sort of thing, which is very different than running inside the container. So we talked about why we want to use containers and what containers are a little bit. Let's talk a little bit about IRIS containers more specifically. So we talked about this picture where we want to run the same thing in each one of these environments. We want to package our software as a container and get consistency in how it behaves by deploying exactly the same thing in each one of these environments. We'll build a container image, a read-only executable software bundle, and then we'll run it as a container in each one of these environments. But there are specific things in these environments that I actually want to be different. Okay? For example, the data. So if I do nothing and I run an IRIS container, the data inside that IRIS, the data that IRIS container will operate on will be mapped inside of it, which means that if I was trying to run exactly the same thing everywhere, then the data would be the same place, the same everywhere, which is a problem, right? Because the production data, of course, is not what we want to be operating in development, especially if we're doing healthcare or finance applications. We want to ensure that we're drawing a strong abstraction line between the data that the container is operating on and the container itself. So we need to ensure that we're running the same portable, consistent thing everywhere for IRIS and the dependencies of IRIS, or your application and dependencies of that on top of IRIS, or however you do it, but the data which it's operating on needs to be different in each environment. So we need a tool, and not just the data, by the way, the IRIS configuration as well. So you might want IRIS in production to have more memory, for example, because it's probably a bigger machine, it's got to perform better than maybe on your laptop. Okay? So we're going to want specific things to be different in different environments for the needs of our application, the needs of our business, while also taking advantage of the consistency that we get across each one of these things. Does this make sense? So, oh yeah, we want to separate the data out. That's what the big arrows are. So we have a feature for this called durable %sys. Okay, this is new in IRIS. Okay, but what durable %sys allows you to do is it allows you to control where the IRIS configuration and the data that IRIS is operating on is. Okay, it will allow you to, when IRIS starts, move the configuration outside of the container, such that I don't need to have the same configuration for IRIS in each one of these locations, but I can have the same application or the same install running everywhere. Right? So when I say configuration here, I mean the security configuration, system databases, the web server, web gateway configuration, the CPF file. If you're familiar with our technology, that's sort of how you configure the IRIS system. Okay, and so what durable sys will do, again, is allow you to move it to a different location. Okay, this exists in IRIS in general, not just in the containerized version. So if you start IRIS with the durable sys environment variable set up, it will move the IRIS config from the install directory to wherever you specified. And if that, and we'll talk about that in a second. So once again, this is sort of what we're doing. I have an example of the command here. So once again, we're doing a Docker run, okay, and it's the same one as I did before, where we're starting IRIS from this sort of the same distribution, that exact container image, that template for running our container. But what I've done is I've done two things. First, I've done a volume command. Those of you who maybe went to the boot camp yesterday might have seen bind as well, but this exposes a directory on the host machine to my container. So remember I said before, in order, these containers are isolated by default. What I'm doing is I'm saying home directory on Mac, that's the squiggly /demo/dir, is mapped to /dir inside my container. So this sort of sets up this linking between a directory outside of the container and directories inside the container. It makes them the same location, basically. And then I'm setting an environment variable. Now this is where durable sys is. So if I set this environment variable to ISC data directory, what that will do is tell IRIS when it starts up to look in /dir/IRIS. And if IRIS finds a valid configuration there, like it's already populated with an IRIS configuration, it will pick up that configuration and start, right? So if that production data and configuration is already in that directory, then IRIS will pick it up and just start running. If it's not there, what IRIS will do is copy its existing configuration into that directory to make a durable sys, okay? And so what this allows you to do is stop this container, start a brand new one, go from 19.3 to 19.4 with your container image, but keep consistency of your configuration and your data through that upgrade. Okay, so it allows you to be selective about what things you want IRIS to have inside the container and what you want it to have outside the container. Okay? So it allows you to make sure that the production data in production is the production data, and that data is not in development, but your developers can still work with the same code base and binaries and container image. Okay, up next is IRIS main. Okay, IRIS main is the other key feature we added to IRIS to assist with some of these needs of running a database application in a container. So we still need more flexibility in this environment besides being able to map our configuration from, map our configuration outside the container so that it's different in development and production. We still need more flexibility here. We need to be able to do things like, is IRIS up or down when I start the container? So if I'm in development and doing debugging, I might not want IRIS to be up when I start the container. Or I might want it to always be up. I don't know, right? So we need more flexibility in how IRIS behaves when we start the container. Okay, what about a license key? I don't care if you run the same license key in production and development, but somebody at InterSystems does, right? Okay, so you might want to be licensing your instances differently. You probably should license your instances differently in development and testing and production. Okay, what about running scripts before or after IRIS comes up? So if I'm in testing environment, I might want to, when I start my container from that template, kick off the unit test suite. Okay, and so this is what IRIS main is going to allow us to do. It's going to give us some flexibility in what happens when the container starts so that I can still be working off of that same read-only image, but have it behave differently in different situations based on my needs, right? So IRIS main is a routine. By default, it orchestrates IRIS in the container. So for those of you who may be more familiar with container technology, this is the main process of the container. But basically, when we build this image, the IRIS image, we specify that IRIS main is the thing that starts when IRIS starts. Okay? And what it will do is start IRIS and then respond to any flags that you passed in to IRIS when the container started. Okay? So when that image becomes a container, okay, it's going to give us this runtime flexibility. I can pass in a key. I can say IRIS is down for debugging purposes. I can pass in a license file. I can run a script before or after. I can change my password at container startup using IRIS main. Okay, by default, it does nothing other than start IRIS and wait for a signal to stop IRIS. Okay, but the point is you have additional functionality, a sort of Swiss Army knife with your container to have the IRIS product inside of it behave slightly differently if you need to. Okay, lots of times this is a debugging tool or for some specific purpose like running automation, running scripts automated when you start the container or licensing, but it is a pretty important part of our container support. So how does it work? Once again, I'm just sort of building on top of my example from before. So I have that durable sys configuration. I have a volume mounted. I have an environment variable set, okay? And then I have my container image. Then after the container image, after I specify what IRIS container I'm running, or what image I want to start this container from, then I have additional flags I can pass it. And here I'm passing in a password file. probably don't want to do this in production where you put a password in a file, but this allows me in my development environment to have when IRIS comes up to set the default password of my IRIS container to what's in this file. IRIS will clean up and that sort of thing. But this is just one example of a command that you can run. So if you start playing with our IRIS containers, and you'll see more examples of this in further sessions throughout on containers, you'll see people use stuff like this a lot. If you pass -- help when you do a Docker run, the container will just exit. Okay, IRIS won't start, but it will print out you all of the options that you have. As I said, there's a lot of things in there. There's like 10 or 15 options, which are really useful as a developer or for doing debugging with containers or setting up exactly how you want the container to behave in different environments. Okay, so we talked about why we want to use containers. We're cutting down on the system drift problem. We talked about what containers are. We talked a little bit about IRIS containers specifically. So let's just do a little recap. Remember the problem that we're trying to solve. Remember why we're working with containers in the first place. We want to have consistency in what we deploy across all these environments. We want to cut down on system drift, and we want to ensure that the code and the dependencies of that code are the same in production as they are in development. Okay? And that we have a standardized tool that allows us to do this. We can build a container image and then use it to run the application consistently across environments. Okay, then there are some terms. We have the container image itself, which is this union of the code of your application and the dependencies of that application. So as I said before, the Java code and the Java runtime, the IRIS application and its dependencies, your application and whatever else it needs baked into that container. Okay, and then we make it read-only so that it's immutable or unchanging, and then we can be sure that it behaves consistently wherever we deploy it. Okay, production, test, dev, in the cloud, on-prem, wherever. Then a container is sometimes used interchangeably with an image for that consistency, but a container is just a running version of an image. Okay, it's one of these binaries that's code and dependencies of that code executed in isolation under resource control. I didn't show it. Other people will show later in the conference more ways to sort of fiddle with Docker to get that resource control and isolation the way that you want. But I showed you a volume command which exposed one directory on my host system to a container which otherwise would be inaccessible. And then remember the IRIS features if you're working with IRIS containers. Durable sys and IRIS main, which are fundamentally there to help you make smart decisions about where your IRIS configuration and data lives inside or outside the container and how that behaves, as well as whether IRIS starts or stops, what the password is, what the license is for the IRIS instance when it becomes a running container. So InterSystems distributes containers on our WRC distribution site. We also distribute the community edition, the free version of IRIS, on the Docker store. And if you just do, pull up the slides later, but store/InterSystems IRIS community. If you search Docker store IRIS or InterSystems, you'll find it. And we're opening a beta program for access to the full paid version of IRIS through the Docker store, as well as an opportunity for customers to give us feedback or ask questions or whatever about our container support. So if you're interested in getting, in an exchange, you'll get early access to builds and that sort of thing, and access to our product and engineering teams to give feedback and questions and that sort of thing. So if you're interested in IRIS and containers, you can go to bit.ly/IRIS-Docker, -Docker, or you can scan that QR code. I'd love for you guys to sign up. I'd love to get more feedback about this, and people who are interested and want to try using it, even if you're brand new, your feedback is valuable. So in addition to this, there are like a million other container-related things going on at the conference. In this room right afterwards is my colleague Sean Klingensmith, who will be talking about containers for developers, which is more geared towards setting up a dev environment with containers, but there's also Skeptic's Guide to Containers. There's Kubernetes and Kubernetes Operator which are maybe more advanced container orchestrator stuff, and then of course cloud sessions, and some of them will be talking about our container support and how that works, deploying instances of IRIS in the cloud. So that's it for me. I'm going to bring up Ben, who's my esteemed guest from Ontario Systems, who's one of our customers who is using IRIS in a container running on Kubernetes. So you're welcome to come on up.
Thank you. As Joe said, my name is Ben Cobb. I'm the cloud architect for Ontario Systems. And Ontario Systems is a software vendor that writes receivables management software, and we've got a bunch of legacy systems and different things. For the last several years, though, we've been working on creating some new technology that are cloud-native apps that are running on InterSystems IRIS, and we've been working a lot of our new technology in that direction. And so Joe asked me to kind of spend a few minutes and talked about where, why, and how we've been using containers. We've actually been using IRIS in containers, or Cache even before it was IRIS, for 2 or 3 years now at least, and have good success with that. So, so before we started using containers, every developer, as you might imagine, had their own system. They would run at least one Cache instance on their system, and they had it customized and configured however they wanted to do so, and they would write their code, and we use version control systems and such. But so we had a number of problems with that. One of the problems, of course, is it worked on my machine issue that I think Joe covered pretty well, and so that's something that we wanted to address, is how do you take a system and make sure it's the same across the developer that wrote it, maybe somebody else that's reviewing that code and testing it, your QA systems, etc. Another problem that we ran into is that we would have projects move around in priority, or urgent things come up, and you have this situation where an engineer is working on this project, they're coding something, and hey, there's this emergency patch that I need you to write and test and get deployed, and it's like, okay, how do you do that? I'm in the middle of this on my system, and so I either have to revert all the stuff that I've done in my Cache instance that I'm working on, and try to reset it up all fresh, and then I'm going to have to go back to it when I'm done with that, or else I'm going to set up a new instance. And so we had engineers that would run multiple Cache cubes on their system until they ran out of resources, and so that whole switching back and forth between things, it was a problem that we knew needed addressing, as well as just bringing new engineers onto a system or onto a project. Or moving them from one project to another. It's like, okay, I've got to reset my whole system up, and I don't really want to do that testing that you want me to do because it might mess my system up, and I've spent hours configuring my system and making it work the way I want it to work, and I don't want to have to redo that. Those are some of the problems that we've wanted to address, and so as we started running in containers, it really did address a lot of those issues, because as a new developer, or as a developer switching to a different project or whatever I'm doing, I can just do a Docker run command, and I've launched a brand new system, fully configured, doing everything that I want it to do. And you can do that either with just like a base IRIS image. So we actually have a base IRIS image based on InterSystems IRIS image that is configured the way we typically configure things. So I want to test out a little something. I want to do a little prototype of something. I don't have to go do it in an area that's shared or that I've spent hours configuring. I just spin up a new container. It takes all of 5 seconds or whatever it takes, and now I can do my prototype there. I can see the results, and I can share those results if I want to. But then I just destroy that container, and I'm on to the next thing. So as I'm switching from one project to the next, I can do that easily. As well as if we've got a particular application, we can store all those the binaries and libraries and such inside the container. We build those images at build time. Then any engineer that wants to start up on this project or test it out or see how it works, it's a simple matter of do the Docker run, now you've got a configured environment that's set up the same way that the engineer who wrote it, intended it to be, and you can test it out and see what happened. And that really does solve a lot of those, well, it worked on my machine, it didn't work on my machine, why is QC different from production, that sort of thing. So it's been a real success for us, especially in the development environment area and into test, which is where we've primarily used it for a lot of time. I think there's other advantages as you start thinking about containers in production, but I don't think we have time to probably get into that here today. So there you go.
Thank you.
You're
That was
welcome.
great. Better job selling it than I did. Yeah, so we're a little over, but does anybody have any questions at this point? As I said, if you think more about it, you don't understand something, come find us. Anybody with an @intersystems.com email address or wearing an InterSystems badge, which would be black or white around the lanyard, can put you in contact with me or somebody else who is an expert on this stuff. So thank you all for coming. Thank you for your time. Appreciate it.